Now I am analyzing the second circuit. Second circuit is again an amplifier, right? So I'm analyzing the amplifier using the frequency response, and I'm plotting the Smith chart again. Or the new Smith chart I'm going to plot. So see the difference between the old Smith chart and new Smith chart. There is some variation. There is some change you can see between the blue color graph. S11 you can see some S11 I have reduced by properly using the frequency of my amplifier. I have changed the reduce the value of S11. S11 is going to be my reflection coefficient at the input side. So now I'm going to cascade, right? So I'm going to cascade everything and design the circuit. Okay, so I'll have first circuit is transmission lines, second circuit is an amplifier, and third circuit is also going to be a transmission line. So I'm writing cascade of circuits, first I'm mentioning the order first, second, and third. And I'm analyzing the cascaded circuit for the given frequency. And what is the frequency? 1, 2, or 2.9 gigahertz. After analyzing, I am drawing the Smith chart. Because when you analyze the circuit, you try to bring the amplifier within the stable region. So I told you, center of Smith chart is always stable. So when both the circles are containing this one point, the amplifier is stable. Previously, you see, this blue circle is containing this one point, but the red circle is slightly away from the one point, so the amplifier is unstable. Previous graph, you see, same thing, blue circle is encircling this one point, the red circle is slightly touching this one point. If you extend this red circle, it's slightly touching the one point. But after impedance matching, what you see here, both the circles, red and blue, red is going to be for the output, blue is going to be for the input. Both are going to touch, both are going to contain my center of Smith chart. So my amplifier is going to be stable. So I have got this cascaded circuit Smith chart. Now plot the S21. S21 will clearly say what is the frequency response of my circuit. Very good. See here, the S21, my design frequency is between 1 and 2.9, right? 1 and 3, roughly 1 and 3. So now it should peak at 1 point. It should peak at close to, at this point, it is peaking. It is peaking close to 2.1 gigahertz. It has a peak response. This is going to be the center frequency of my amplifier. My amplifier is working at 2.2 gigahertz. Next one, I am plotting what is the noise figure. You know, a noise figure, this is your S21, this is your noise figure. The noise figure has to be important parameter for any amplifier, and you know that noise figure is SNR at the input, SNR at the output. Ideally, noise figure has to be 1. Noise figure value should be 1. For dB scale, you can say noise figure has to be 0 dB. But practically, all the amplifiers will not have very high value of noise figure. So that is the thing, and we have seen the noise figure visualization. See here, the ideal case, it should be at 0. Ideally, it should be at 0, but at the frequency of interest, it is slightly high because of the non-linear nature of the amplifier. That is what is evident from this example. This is one another example where we have seen how to cascade different RF elements at high frequency and measure the frequency response and see all the properties of the RF circuit. Okay, so that is the example we have seen here.